let's look at the first item, total connected gas load. And so what we're going to be doing is we're going to be looking at the 500 CFH for cooking, 200 CFH for the water heater for the kitchen. This is probably an elementary school because there's no athletic area. There's no shops. So I kept it simple. We've got rooftops. So we want to add up all these 60 CFH, 200 CFH, 120 CFH, 200 CFH, and come up with a total CFH, 2,000 CFH. So let's do that. Can y'all do that? I think it's 15. There's 15 at 60. I did it earlier. So that's 900 plus 400 for the, plus 400 plus 120. That's 1420. And then add in the cooking, that's 500 plus 200 for the water heater at the kitchen. Oh, wait a minute, generator. They come on when the power's out, right? So do we need to include that in the total? The building's down. Why would we include the generator?
You say yes.
Yeah, because it still needs to be supplied either way.
Yeah.
Because they have to test it periodically, and they may be testing it when it's cold outside. We're using a lot of gas, and it's during lunch hour. So yeah, we're going to add that in for the total. 2,000. And what else? Was there anything else? So we have our rooftop units, got our cooking, gas water heater, generator. And I come up 4,120?
4,120, yes, sir.
Okay, cool. So that's 4,120 CFH, which is also 4,120,000 BTUH, right? Okay, so it's 4,000, and I'm just going to leave it at CFH. And then the total gas without the generator is 2,120. Okay, longest run. So if the gas meter's here, we've got 200 feet to the building. So let's add that up. You got 200 feet. Prerequisite is calculator. Everybody needs to have a calculator. And then I'm going to go ahead and this does not have to be precise. We just need to be close. In other words, we're 200 to here, and then it's 200 to there. And I drew this in on purpose. So if we're going to probably run our gas line right through here on the roof, we could say 125 from there to there. So that's another 125 plus. So that gets us to here. And then we're another 400. And I'm going to go ahead and say 500 because we're going to allow for the future addition. So plus 500. What about vertical? Is horizontal all we have to worry about? Does gas care if it's horizontal or vertical? No, it's still pressure drop, right? So let's go ahead and add in another 25 feet because we're below ground coming up to the roof. Let's make it 20 feet. 845, is that what y'all have? I'm at, okay, 845. And that gets us all the way to the furthest future addition. This is very close to the gas meter, so. And then what do we do in domestic cold water when we have to adjust for fittings, valves? We multiply times 1.5, and it applies here as well. So 845 times 845 times 1,267 feet. 1,267 feet. That's our longest run, 1,267. So would you say we'd round up or round down? Round up. So this table, everyone, and Jordan, I need to get you a copy of the laminates. So we're looking at the line that we're dealing with, the 5 pounds, so it's medium pressure. And so it's going to be this bottom table. And we're at 1267. So 1,500 feet is the column that we would use. And what was our gas load? 4120 CFH. 4120, 3-inch gas line, 1,500 feet, and it'll serve 5,990 CFH. So longest run was 1267, but we're going to use 1,500. Gas company extension length was 600. Original building square footage was what? 80,000? What's the future addition square footage? This one is 100 times 100. That's what, 10,000?
Yes.
So we're at 10,000 square feet here. And then this one's 8,000 square feet. Okay, so we've determined our longest run. Gas company extension length is 600 feet here. We're going to use that number when we get the cost estimate back from the gas company. And then we say, well, we can divide that and calculate a cost per foot for future projects. You know, if we want to compare costs from gas companies, kind of start a database. Original building square foot's 80,000. The future square foot was 10,000, 8,000, so we're at 18,000. And then we're going to calculate the B2H per square foot based on the original building. So if we were at, and you got to make sure you convert it back to B2H, otherwise it doesn't make sense. So we're at 4,120,000 for the 80,000 square feet, B2H. And that comes out to what? 51.5 B2H per square foot. I'm just using a little box. So if we know what our future expansion is, then we just multiply 18,000 times that to coordinate with the gas company and let them know that. So the 18,000, what is 18,000 times 51.5 B2H per square foot?
927,000.
927,000. And the original was 4,120,000?
I believe so, yes, sir.
Okay, so and this is if you've got a good idea of the square footage. So now our new load is 5,047,000. And that covers the future expansions or and once we get into gas and you guys start sizing, I'll go over some other advantages of this table versus a higher pressure drop table that's in the NFPA that we use for existing buildings. Because the higher pressure drop on existing buildings allows us to reuse smaller lines versus this. This is only a 10% drop. Y'all know what that means. If we're starting off at 5 PSI, then we're ending up at 4.5 PSI. So it's very conservative and it allows the owner room for expansion. So, I mean, we could size it based on this and go back and look at the higher pressure drop table and see if we can cover these future expansions if they want to BE out cost without, you know, maybe make the line size smaller. So now let's do this. Now we got to go back and, well, we looked at that a while ago. 1,500 feet, 3-inch. Let's see, 1,500. Say, yeah, we're at 5,990. So we're still good on the future expansion with a 3-inch.